All right, so we're going to be doing the check your understanding for topic 3.1, which is the chain rule. So we're here. We've got this problem. The first thing we want to do is identify what the inside function is and what the outside function is, or basically where square is. So let's just talk about square. We use that notation in class. We talked about that here. Square, the complicated portion, or the inside. So this function would be really easy if it was just e to the x, but it's e to the mess. So the square is basically the mess 90% of the time. So it's going to be 3x squared minus 7x. Okay, and so then I will have e to the square. Okay. And so that's going to be f of x, not f of square, f of x. So we're going to find f prime. So that's equal to e squared times d squared dx. Wow, what a mess. Sorry about this. Okay, so d squared dx is equal to 6x minus 7. That's the derivative there, power rule. And so f prime of x is e, and we're going to substitute. So e squared is 3x squared minus 7x times d squared dx, 6x minus 7. Okay, and there's my answer. So number 2 is quite a bit more complicated because it's actually got a lot of functions going on in that one. So when we look at number 2, 3, sorry about that. Go ahead and we're going to rewrite that down here. G of x is equal to cosine cubed of 4x. So it doesn't look all that complicated. Let's rewrite it again. Cosine of 4x cubed. So remember, that's just shorthand notation for this, and this is more helpful. So I've got a couple things going on here. So square, I think, is 4x. So that would mean I'd have g of x equals, and let's play color games here. Call square blue, so I'm going to use blue for square. I'll erase the rest of that in a minute. So I have cosine of square cubed, and so I still don't have like just the square there, so we're going to go ahead and go with another color here. So there's my square. It's blue. Let me make it blue. Then we're going to get triangle. So triangle is going to be cosine of square. Okay. All right, so then I have g of x equals triangle cubed. Okay, so now I'm down to something simple. So let's go for it. G of x, g prime of x is equal to actually ask for dg dx. Let's write that the way they asked for it. It's going to be 3 triangle squared d triangle dx. going up here, d triangle dx is equal to derivative of cosine is negative sine square, blue square, d squared dx. Okay, then, so I need that, which I don't have. D squared dx is equal to 4. So I took the derivative of that one. That's 4. Okay, so here we go. dg dx is equal to 3 parentheses triangle, which is cosine of square, which is 4x, to the second power. So all I've done is replace this. Okay, so triangle is cosine of square, so I've plugged everything back in. Times d triangle dx, and d triangle dx is negative sine of square, and square is 4x, times d squared dx, and d squared dx is 4. So there's my answer. Now what I've done here is the work I'd actually write down. So if this was my problem and I was confronted with this, I would rewrite it like this. Then I would take the derivative using the power rule of the outside. Then I would look inside the parentheses and I see cosine. Derivative of cosine is sine. Negative sine. So derivative there, right there. Then I look inside again and I take the derivative. Again, this is a double chain. Double chains are harder. Final answer. dg dx is equal to 3 times 4, which is 12, and then there's the negative sign, so negative 12. I'll put sine first because it doesn't have a power, times cosine of 4x, and cosine squared like that. That'd be the answer on the multiple choice. There you go. So it is a little tough, so don't feel bad or frustrated or upset that you're getting things wrong. It's all good. We'll move forward. So let's take a look at number 3. Find the derivative of. So again, the first things we want to do is identify pieces, figure out what things are, see what's going on, decide. And I'm going to go ahead and write my answer for number 2 on here. dg dx is equal to negative 12 sine of 4x times cosine squared of 4x. Okay, so anyway, let's get that down. All right, find the derivative of. So there's my problem. And what makes this complicated? Well, is this. So I could rewrite this as y equals negative 7 over square cubed. And square this time is 2x minus 3. I'm going to go ahead and write down d squared dx while I'm at it is 2. I'll leave that in a minute. And so then let's rewrite this. We've got y equals negative 7 square to the negative 3. Okay, so let's go ahead. Let's go for it. Y equals negative 7 times negative 3 times square. I'm going to go ahead and make square really big here so I can fill it in. Negative 4 times d squared dx. Maybe I won't fill it in yet. Which is doing some substitution, positive 21 times square 2x minus 3 the negative 4 times 2 d squared dx. So square d squared dx. Continuing, y equals 42 over 2x minus 3 to the fourth power. So C. Okay. There you go. Number 4. Selected values of two differentiable functions are given in the table below. Let's see what's going on. So we got all these. We've got f, f prime, g, g prime, and then we have k defined right here. So k of x is defined as f of g of x. Find k prime. So let's find k prime of x is equal to the derivative times the derivative of the inside function. So derivative of the outside, the inside function stays there because that's going to be the key here. So we want to find k prime of 3. In order to do that, I need to know. So let's just go ahead and plug in and see what's going on before we go and look for what we need. So I'm going to use my paper again. So I'm going to go k prime of 3 is going to equal f prime of g of 3 times g prime of 3. So I need to know g of 3 and g prime of 3. So let's look at our chart and see if we can find those. So we're looking at 3, and we want g of 3, which is 6, and g prime, which is 2. Okay, let's see where we're at now. K prime of 3 equals f prime of g of 3 was 6 times g prime, which is 2. Okay, so now I need something new. I need f prime of 6, which I didn't need before, but now I do. So 6, f prime is 5. And so continuing here, now I have k prime of 3 times f prime, which was 5, times the 2 I already had. K prime of 3 equals, which is equal to 10. Okay, so now I have k prime of 3, cool. So, writing over here, k prime of 3 equals 10. Now, it asked me to write an equation for the tangent line 2k at x equals 3. Okay, so to write an equation of a tangent line, I need the derivative, the slope, and I need a point. I have the slope. So I'm going to need k of 3 and k prime of 3. K prime of 3 I already have. I found it in the previous problem. It's 10. K of 3 I need to find. So k was again defined as f of g, right? Yeah. F of g of that. I'm going to go like this. That way I can have my table here when I need it in a minute. So I want to find k of 3. It's going to be equal to f of g of 3. I found g of 3 already. It was 6. So f of 6, which I haven't found yet, f of 6 is 4. And so k of 3 is equal to 4. So now I have this, and I'm going to borrow that from the previous problem, right? So I have these two things. We can write in our equation. We need y equals m parentheses x minus x1 plus y1. And so y equals m, slope is 10 at 3, x minus 3, that's our x value, plus our y value, which was 4. And there's my answer. All right, so good luck with these. Again, table reading, this type of problem all over the AP test, all over. We're going to practice some more of those on Thursday. So we're going to see how often they show up. All right, good luck. I hope you have a great afternoon. I'll see you guys on next time.